So let's say you've gathered data and you're trying to figure out whether it's reasonable to think that this data was gathered from a population which is distributed normally. So I grabbed a whole bunch of people and I asked them all to try to solve a puzzle, a fairly simple puzzle, and I want to see how long it takes them, and I time how long it takes each person to finish the puzzle. And I want to figure out, here's the data I gathered, in histogram form or in box plot form. I want to figure out whether it's reasonable to think that puzzle finishing times in the population would be distributed normally if I made absolutely everybody solve the puzzle. Maybe I'm considering using it to help me create a new IQ test or something like that. Is it reasonable to think that these are distributed normally? Well, looking at the histogram, does it have the features of a normal distribution? Does it have a single peak in the middle and trail off equally to both sides? Well, it does have a peak, but it's significantly to the left of the middle of the distribution. Now, if I was gathering a sample, I'd expect a sample not to match the population perfectly because I only gathered like 50 people. You're going to have variation due to just who you happen to pick, right? Normal variability means that it won't look perfect every time. But is this vaguely in the shape of a normal distribution? I would say no, it looks skewed right. There are exceptions way off to the right, there aren't any exceptions way off to the left of the peak. If you think of this as where the peak should be, I mean, if it was wider and shallower, then why aren't there things way out there happening more often? If it's narrower and taller, why are things way out here happening reasonably often? This doesn't seem to fit the distribution well, so if you got data that looks like this, you would say, no, it's too skew right and asymmetrical. This doesn't look to me like a normal distribution. Also, it doesn't have a peak that is peaky enough in the middle. Although theoretically, this sample could have been drawn from a normally distributed population of puzzle solving times, the data doesn't suggest it. So the clues here, looking at a histogram, are it's not symmetrical, it doesn't have a single peak more or less in the middle, a more or less single peak in more or less the middle. So this doesn't look normal. Now, can we detect that the box plot isn't normal? Well, first of all, it's not symmetrical. Here's the median. The median should be where the mean is, which is in the middle if it were a normal distribution. And the points to the left of it are much more closely stacked than the points to the right, which are much more spread out. Recall that 50% of all points are above this, 50% of all points are below this, so that's a lot of points stacked into a narrower space over here. The fact that it's not normally distributed, the fact that it is not symmetrical, is one clue that tells us that this is not normally distributed. Another one is that since the normal distribution has a lot of points near the middle and a lot less points out towards the sides, what we should be seeing in a normal distribution is a lot of points all close to the middle. So the middle 50% are all close together, while the outer 50% are much more spread out. Theoretically, if a distribution was normal and you got some data and you put it in a box plot, data from the population, your sample looked like this, it should have a lot of points close together in the middle and a few points spread out at the edges. And so because this doesn't look anything like that, we would say, this area, this band looks smaller than this band, it doesn't look normally distributed. Yeah?